Okay, today we are going to talk about solving systems of equations using a new method. And we're going to call it the elimination method. You'll see why in a second. So let's just recap real quick. So we've solved systems of equations using the graphing method, where we graph both of these. We've solved it using the substitution method, where we solve for one of them and then substituted that into the other one. Now we're going to learn the elimination method. After today, you could use any method you want. A lot of people really like using the elimination method, but yeah, they're all doing the same thing. And remember, and we'll talk about this a little bit later on, but what are we trying to find? We're trying to find the ordered pair that these two intersect at. Great. Okay, so some of you might be thinking in your head, well, substitution, I could solve for y or solve for x. Substituting the other one, life is good. Okay. Well, think to yourself. You have a positive y here and a negative y there. What were to happen if you were to, let's just say, add those together? Well, y plus a negative y gives me 0y. And now let's try adding everything else together. X plus a negative 7x is a negative 6x plus that 0y. And that equals negative 7 plus negative 11 is negative 18. And we know that anything times 0 is 0, so we could get rid of that. We have negative 6x equals negative 18. Then doing some crazy math, x equals 3. So using this elimination method, we eliminated the variable y, and then we had x by itself. Now that you know what x is, so x is equal to 3, remember that's the ordered pair where these two intersect. And that's also the ordered pair that works for this one and at the same time works for that one. So to find the y, we can use this x equals 3 and substitute it into either one. It doesn't matter. I'm going to use the first one just because it's there. So I know that x equals 3, so wherever I see an x, I can replace it with 3. There's an x. So now I have 3. There's the bell. So 3 plus y equals negative 7. So instead of x, I replaced it with 3. Now you can solve for y. Subtract 3, y equals negative 10. Remember, you could have used that one too, you get the same answer. Now we just write our answer as an ordered pair. Three comma negative 10. So, Mr. Pons, what does this mean? Well, great question. Remember, this is just the ordered pair that works for the first one and also works for the second one, and that's where those two lines intersect. If you were to graph these, you'd see that. Use substitution, you see that. Now we just see a different method. So elimination is probably the most efficient method because you see how quickly we're able to get the answer. But again, each system calls for a different approach, I guess you could say. Okay, so we're going to try another one. We'll try another one together, and then you can do one by yourself. Let's say you have this one. 2x minus 3y equals 5. And so take a second and try this one by yourself. Welcome back. Okay, so what we first want to do, before we do anything, we want to see if there's any way we can eliminate a variable. Well, look in here. I can't eliminate y, because negative 3 plus 6 doesn't give me 0. But negative 2x plus 2x does give me 0. So in this case, I'm going to eliminate x. So add these together. Negative 2x plus 2x gives me 0x. Negative 3y plus 6y gives me a positive 3y. And then 5 plus a negative 8 is negative 3. So that gives me 3y equals negative 3. Because anything times 0 is 0. So y equals negative 1. Now that I know what y is, remember, you can substitute it into this one or this one, and you can figure out what x is. Since we did the first one last time, I'll use the second one this time. Okay? So substituting in y, I get 2x plus 6, and instead of y, I'm going to put negative 1. This is y equals, oops, let's color code these guys. Now look, you have one equation with one unknown. So 2x, 6 times negative 1 is a negative 6. Add 6 to both sides. 2x equals negative 2. So x equals negative 1 as well. Now we just write as an ordered pair, x and y. So again, this ordered pair is where these two lines intersect. And we were able to solve this using the elimination method. You see, if you were to use substitution, it might get a little bit sloppy, depending on which one you solve for. Okay, now we're going to have you try 2 by yourself. And let me know how it goes. Okay, first one you could try. Okay, so that's the first one you could try. And that's the second one you could try. Okay, so looking at the first one here, got to pick a variable to eliminate. Well, if you were to add the x's together, negative 4 plus negative 8 doesn't cancel it out. Okay, look at the y's. Negative 9y plus a 9y gives me 0y. So y is the one I want to eliminate. So I'm going to add these two together. Negative 4x plus a negative 8x gives me a negative 12x. Negative 9y plus 9y gives me a 0y. 8 plus 16 is a 24. Anything times 0 is 0. So negative 12x equals 24. X equals negative 2. And then you can pick either one you want. We could use the first one, I guess. So you get negative 4 times, and instead of x, we're going to substitute in negative 2 minus 9y equals 8. You see this? Instead of x, we put in negative 2 because that's what we know what x is. Negative 4 times 2 is 8. Minus 9y equals 8. Get y by itself. So negative 9y equals 0. Then you divide each side by negative 9. Don't forget that negative sign. But 0 divided by anything is 0. So y just equals 0. So our ordered pair here is negative 2, comma 0. And remember that you're thinking to yourself, okay, well that's the ordered pair that these two lines intersect. Okay. Hey, even try. Try substituting a -2 into the second one. You'll see you'll get y equals 0, hopefully. Okay, this one here. Well, got to pick a variable to eliminate. Look at this. 3x plus a -3x. Those cancel out. Sum up to 0. So let's add those. That gives me 0x. 8y plus a -8y. Wait a minute. Gives me 0y. 15 plus a -10 is 5. Well, these are both 0. So 0 plus 0 is 0. 0 equals 5. Now, Mr. Pons, what does this mean? Well, think to yourself, does 0 equal 5? No. This is not true. So that means our answer is no. And if you think about it in terms of a graph, remember we're looking for where they intersect. So if there's no solution, what's that mean? Your lines are parallel. Okay? If this were infinitely many solutions, that means that our lines are the same line. So no solution just means the lines are parallel. Okay. Hopefully this helped. Hopefully you see this is a little bit more efficient. Picture if we had to do substitution on this guy. Ugh. Okay.